Hello, good afternoon. Today we're going to be looking at recursion, and here we're going to be looking at so many examples of problems that we can solve using recursion. And among the problems we're going to solve today is using recursion to determine factorial. We're going to learn how we can use factorial to generate Fibonacci series. So this is Fibonacci series. We're also going to see how we can sum up natural numbers. Some natural numbers. Then we're looking at how we can do string reversal. Then we'll look at power of exponentiation. We're also going to look at greatest common denominator, common factor. Greatest common denominator. Then we're going to look at how to determine whether a series or a collection is palindrome. Then we're going to look at arithmetic progression. So have arithmetic progression. And then finally, we're going to see how we can do binary search. So, but before we start solving all these problems, it's important that we understand what recursion is all about. So what is recursion? Recursion is a way of solving problems. And basically what it involves is when you see a problem, you can find a way of breaking the problem down to the level that you know, and that becomes your base. And from there, you now start solving the problem. So it's considered to be one of the ways of, or the approach for solving problems using an algorithm concept known as divide and conquer. So when you want to use recursion to solve a problem, there are two important concepts. One is establishing the base case. Then the other case is you have the recursive steps. These are the two key steps involved in solving problem using recursion. Then another thing again about recursion is that if you want to define recursion, you can say that a recursive function or a function is considered to be a recursive function if it calls itself. Within that function, you call the function within a function. That makes the function a recursive function. So we're going to start by looking at the factorial. So what is factorial? If you're asked to provide the factorial of a number, the factorial of a number is when you multiply all the numbers, all the natural numbers that fall along that particular numbers together. It's going to give you the factorial of that number. For instance, if you're asked to provide the factorial of 5, factorial of 5 is simply 5 multiplied by 4, multiplied by 3, multiplied by 2, and multiplied by 1. That is the factorial of 5. So what is the factorial of 3? 3 factorial is the same thing as determining the factorial of a number. So if you want to determine the factorial of a number programmatically, factorial of a number using iteration, then we'll see how we can get the same outcome using recursion. So if you want to use iteration for this, what you need to do is to generate numbers between 1 and that particular number and have those numbers multiply themselves. It is going to give you the factorial. So we can call this DEF factorial. And this is the number that you want to determine the factorial. So let me put it as num. So here we're going to have result is equal to 1. I'm going to initialize result to be equal to 1. Then I'm going to perform a loop this time around. So I'm going to have 4. Maybe I in range. I need to get 1 to that num. To make sure that the number is included, I'm going to have num plus 1. Num plus 1. So this is going to make num to be inclusive. So here we can have result times equal to I. Then we'll now return the result. So have return result. So now let's call the function to use it to determine the factorial of a real number. So I'm going to have maybe result is equal to, here I'm going to have factorial, and I will have 5 here. 5 is the number I want to determine the factorial. So I'm going to do print result, and this is going to give me the factorial of that number, which is 120. If I want to get the factorial of 3, I'm going to change this to 3. This is going to give me the factorial of 3, which is 6. So this is 3 times 2 times 1, which is going to give you 6. So if you want to solve the same problem using recursion, one thing, so we have factorial of 5. We don't know. So what do we know? We know that the factorial of 1 is 1. That is what we know. And we also know that factorial of 5 is the same thing as 5 multiplied by factorial of 4. That is one thing we know. So this becomes the base case, and this becomes the recursive steps that you're going to take. So we're going to represent this programmatically. So to do this, we're still going to use a function. So I'm going to have def, and I'll call it factorial. And in this case, I'm going to put num. So the first thing we're going to do is to establish our base case. So if num is equal to 1, then we can say return 1. And then what happens in other cases, then we'll now have else. We'll have return num multiplied by factorial of num minus 1. So this is a recursive call. It will keep on calling itself until it gets to the point where n minus 1, that's num minus 1 is equal to 1. When it gets to that level, it is going to return 1 for us. So ultimately, it's going to keep on multiplying itself until it gets to 1 and return the value which we know, which is 1. So let's go and go ahead and run the program. So I'm going to have result is equal to factorial. Here I'm going to have 5, and I'll go ahead and print result. So this is going to give me the factorial of 5, which is 120. And if I try to get the factorial of 6, it is going to give me 120 times 6, which is 720. So this is how we determine factorial using recursion. So the next thing we're going to look at, we've looked at factorial. The next thing we're going to look at is Fibonacci series. So what is a Fibonacci series? How does it look like? So I'm going to give you an example of how a Fibonacci series looks like. So it looks like this. The first number in the series is 0. The second one is 1. Then subsequently, other ones is the sum of the two preceding numbers. So now we have two preceding numbers, which is 1 and 0. So the next one is going to be 0 plus 1, which is 1. The next one is going to be 1 plus 1, which is 2. The next one is going to be 2 plus 1, which is 3. The next one is going to be 2 plus 3, which is 5. The next one becomes 3 plus 5, which is 8. Then the next one becomes 8 plus 5, which is 13. So how do we go about determining or generating this series using recursion? So first of all, we're going to start by identifying our base case. Our base case is that if you're asked to produce a Fibonacci series with one item or with one number, you are going to give 0. If you're asked to produce a Fibonacci series with two numbers, you are going to give 0 and 1. Then this is the base. Then subsequently, what you need to do is, if you're asked to produce the Fibonacci series maybe of 3 numbers, you know 0 and 1 is for 2 number Fibonacci series. So the next item is going to be 0 plus 1, which is going to give you 2. And this is how it is going to continue until you exhaust the number that you were asked to generate. So what we're going to do now is that we're going to start by defining a function that is going to generate Fibonacci series for us. So how do we do this? First of all, we're going to have DEF. Let me call this function Fibo. Then we're going to have the number of items or the number of numbers in the series. So this is what we're going to provide as the parameter for the function. So in this case, I'm going to write num, and then I'll put my colon. So the next thing I'm going to do now is that I'm going to identify the base case scenario, and that is if num is equal to 0, what are you going to return? So if it is 0, you are going to return just a list with 0 as the item there. Then if, that is elif num is equal to 1, it is going to return you are going to return this, that is return. So this is what you are going to return, 0 and 1. So this is what you return if the number is equal to 1. So what then happens if you are asked to provide more than one number? What then happens? So what you are going to do now is that you are going to have a sequence. We're going to make use of a sequence. So we can say sequence is equal to, and here we're going to call on the Fibonacci series function, which is Fibo. Here we're going to pass in num minus 1. Then the next thing we're going to do is that we're going to perform an appending. And in order for us to do the appending, we're targeting the last and the second to the last item in the already existing list. So what we're going to do is we're going to say sequence dot append. Here we're going to have sequence. Here we're going to target the last item and then minus 2. And then we'll return the sequence. So have return sequence. Calling the function. So I'm going to have result is equal to, and for this result I'm going to say Fibo, and I'm going to put in 1. So let's see the type of series it's going to give us and say print result. If I say print result, it's going to give me 0 and 1. So but what if I say 2? 2 is going to give me 3 numbers. which is because the base case is that we know that this is what we know. This is what we know. We cannot manufacture this on our own. But we know that once the number exceeds 2, the next item becomes the sum of the two preceding numbers. So if we say 2, we're going to get something like this, 0, 1, 1. Then if we have 3, 3 is going to give us this. So this is how we go about generating Fibonacci series. Then the next thing we're going to look at is we're going to look at how we have natural numbers. But first of all, what are natural numbers? These are the common numbers that, and the thing about natural numbers is that they flow in a pattern. You have 1, you have 2, you have 3, you have 4, you have 5. And so next item seems like you added 1 to it to give you 2. 2 plus 1 will give you 3. 3 plus 1 is going to give you 4. So the first thing you are going to be needing is how many natural numbers do you want? Assuming you want, you are given 5 natural numbers, it means get me the sum of 1 to 5. 10 natural numbers means 1 to 10. 20 natural numbers means 1 to 20. So that is the numbers involved in the natural numbers. So how do you go about determining the sum of the natural numbers? So first of all, let's have DEF, and we'll call this sum NAT. And then we have num. And this num represents the number of natural numbers that we want to add up. So we have num as our parameter. Some of the natural numbers, we know that if you are asked to provide the sum of 0 natural numbers, the answer is going to be 0. That is what we know. So we can say that if num is equal to 0, return 0. That is what we know. That is our base case. Then, if not like this, this is what we're going to return. So have return. What we know is that if you have natural numbers like 1, 2, 3, 4, and 5. 5 is the number of natural numbers, and the highest number there is 5. So what we know is that the sum is always going to be num, which is the highest number initially, plus you can now say sum net. That is calling the function again. This time around, you are going to say num minus 1. So this is going to be calling itself until it gets to num equal to 0, and it is going to return 0. So what happens here is that you are going to have 5 plus 4 plus 3 plus 2 plus 1 until it gets to the point where n is equal to 0, and then the function is going to return 0. So this is what happens. So let's go ahead and run the function. So I'm going to have result is equal to sum. Let's have 5. So let's go ahead and print the results. So if we print the results, we're going to get the sum of the natural numbers, which is going to be 15. So if we want to get the sum of natural numbers that are 100 in number, we're going to put 100 here. So this is going to find sum of natural numbers 1 to 100, and the value or the answer is 550. So this is about natural numbers. Then the next one we're going to look at is how we can use recursion to do string reverse. And you want to reverse this string. What you are going to get is the last character becomes the first one. So we're going to get something like OLLEH. That is reversing the string. We can as well do this using iteration. We can as well do it using recursion. So let's see how we can quickly get the string reversed using just slicing. We'll do that with iteration, and then we'll now use recursion to do the same. So I can simply say result is equal to Then I'm going to have hello. Here I'm going to use my slicing operator. I'm going to have the step to be -1. So this is going to reverse the string. And I can say print result. So if I have it as print result, it's going to reverse the string. Then another option of reversing this string is by making use of a loop. You can also use a loop to achieve the same thing. So let me use a while loop to do the same thing. So let's say we have a word is equal to hello. And in this case, I can have count is equal to, okay, let's start by count is equal to, I want to determine the number of characters there. That will help me perform the loop. So I can say word count is equal to, here I'm going to have len word. This is going to give me the word count. So then I can say while word count is, maybe I can have something like this, because what I want to do is I want to perform a loop on this starting from the last item here. And we've established that the word count is len word, which is going to give us 5. So I'm going to have an empty word. Maybe I can say reversed word is equal to empty string. So this is my reversed word. Then the next thing I'm going to do is I'm going to have while count is greater or equal to, is less than, word count. So for this is supposed to be word count. While word count is so this is the reversed word. So I'm just trying to see, it's been a long time I used the while loop, so this shouldn't be a problem at all.